We now look at the implications of undecidability when either assessing or comparing static analysis tools. Let's distinguish between decidable and undecidable rules. If you've got a decidable rule, it means that 100% enforcement can be achieved. However, just because a rule is decidable doesn't mean it's easy to enforce. So there are semantic nuances both in the underlying language and in the coding standards, and these semantic nuances can interact with each other and lead to possible misinterpretations. So occasional false positive and negatives are not uncommon. If a coding standard is used, then consistent interpretation across tools can be supported by the underlying working group. When a false positive and a false negative is confirmed, this should be acknowledged as a shortcoming of the tool. So any attempt to discredit the assessment criteria or the samples as being unfavorable, if the rule is decidable, these are bad signs. The situation is different for undecidable rules. In the case of undecidable rules, 100% enforcement cannot be claimed. However, partial enforcement is possible, and therefore undecidability is not a good reason to give up enforcement. And also, samples can always be found that are favorable to one tool and unfavorable to the other. So it is possible to have objections to the assessment criteria, which may or may not be justified, and a way to decide whether they are justified or not is to look at how complex are the samples selected in the assessment. So if they are fairly simple, then there's little margin for objections. However, if when we go above a certain level of complexity and software for static analyzers is to be further developed, the focus may shift from clearing any false positive or negatives that are discovered or reported to actually pushing the state of the art deeper in a specific direction. And different tools can move in very different directions. The horizons are very wide.